Alright, P0868 secondary pressure down. This is a fairly common code for like flow control valves and pulley problems. So the description is a pressure control solenoid valve B regulates solenoid secondary pressure to suit the driving conditions in response to signals sent from TCM. So what it's looking at here is it wants the computer commanding secondary pressure, and it's looking in the scan tool or looking at the information from the secondary pressure sensor, and it's not matching what it thinks it should have. So it's going to go ahead and set the 868 code. On the scan tool, you can look at PID secondary pressure on the scan while idle in neutral. The PID should be roughly 0.5 milliamps or megapascals. So what we could have here, we could have harness or connector issues. If this was the issue, usually this sets a code P0778 with it. So if you have that 778 code along with the 868 code, fix the 778 code first. Problem with the pressure control solenoid valve B, transmission pressure sensor, secondary pressure sensor, problem or issue with the sensor itself, and then a leak in the line pressure control system. Check line pressure and secondary pressure is a good idea with this. A lot of times you can also do this on the scan tool. Drive it hard and you will see this code pop up. A lot of times this is the flow control valve in the valve body or in the pump. '1705 throttle position sensor. So we're talking about the electronic throttle control actuator and the throttle control motor and the accelerator pedal positions. Basically, this system works all together from the ECM, TCM, and CAN bus. So when the TCM does not receive the proper accelerator pedal position sensor from the CAN bus system from the ECM, it's going to set this code. So what we need to do is look at the ECM and see how the throttle actuators, the accelerator pedal position sensor, and throttle control motor are operating. This usually is a bad ground, bad battery, charging system issue. So the first thing they want to do is shut the throttle response down if they have inaccurate signal. P1722 vehicle speed. The vehicle speed is from the ABS actuator or the ABS unit, from the CAN bus system to the TCM. When it sees a big difference from the ABS actuator and the vehicle speed signal, which is the secondary speed sensor, when they see differences on those two PIDs, they're going to set this code. So you can look at your vehicle speed sensor and your estimated vehicle sensor PID. And you can also look at your secondary speed sensor code, secondary speed sensor RPMs also. This usually is a problem with wheel speed sensors, ABS, power and grounds. Those kind of things are the most common issues. One note I'd like to say is ABS wheel speed sensors, not always setting codes even if they're erratic. So make sure you always check your wheel speed sensor codes on every one of these. 1723 CVT speed sensor function. So this is talking about your secondary speed sensor, and secondary speed sensor is reading off the part gear, and the pulse signal is sent to the TCM, which converts it to vehicle speed. So the set condition, what is this code setting for? It says diagnostic trouble code, CVT speed function is detected when there is a great difference between vehicle speed and secondary speed sensor. The rotation sensor, so this is basically like the last code, vehicle speed. The difference here is they are blaming this one, or they're looking at the stepper motor. So they're changing the steps in the stepper motor, which should change the ratio, and it's not detecting the speed change. So how you would test for this is on the scan tool, you want to look at your stepper motor counts and your ratio information. When you see the stepper motor counts change, the ratio should also be changing. So if it goes up, the ratio should be changing. If the stepper motor counts go down, the ratio should be changing. Need to inspect the operation of the primary speed sensors, secondary and engine speed sensors. Wheel speed sensors, ABS, are also a good idea to check. Grounds are also a common problem. Alright, so DTC P1740 Lockup Select Solenoid Valve Circuit. So the description of the Lockup Select Solenoid Valve, it controls lockup clutch pressure and or forward clutch pressure and reverse brake pressure. So when you have a problem with the Lockup Select valve, you're going to have some engagement issues forward and reverse, and no lockup. So normal voltage on this, so the normal voltage is not applied to solenoid due to cut wire, short circuit, etc. So what they're saying is the voltage is not correct on that circuit, and that's what it's setting the value, setting the code for. The TCM is looking at a target value and a monitor value. So the PID information we'd be looking at would be the Lockup Select Solenoid out. On the scanner should read on in neutral and off in drive. About 5 seconds after the engagement. Here's the Lockup Select Solenoid circuit. Just one wire. The solenoid's grounded to the valve body, just like the other solenoids. For design 1, we're looking at pin 4 at the TCM. So pin 4 and pin 13 at the transmission case connector. These are the same wire. So to check the TCM, you can unplug the TCM and check pin 4 to ground. You should have about 6 to 19 ohms. That's the ohms of the solenoid. So if you're monitoring the wire itself, in neutral, let's see here, you should have battery voltage in neutral and 0 volts in drive. So after the engagement, it's going to take roughly 5 seconds and the voltage is going to drop to 0. And this is for the engagement feel, is what they do that for. So on pin 37, this is design 2, TCM. Pin 13 still is the transmission case connector. You should have battery voltage in neutral, and it's dropped to 0 volts in drive. Same thing as the other design 1. It should take about roughly 5 seconds after the engagement, and the voltage should drop to 0. 1745, line pressure control. This is pressure control solenoid valve A, where again we're regulating pump pressure. TCM is commanding the amperage through the solenoid to control line pressure. So set conditions. Low pressure control is detected when TCM detects the unexpected line pressure. For some odd reason, the factory scan tool, and I had to read this over again just to make sure it was correct and I'm not thinking wrong. They say in the factory manual that the TCM is the only component in the list that's going to cause the P1745 code. Very misleading, in my opinion. We need to check the operation in other codes before we do all of this other stuff. But if you get a 1745 code, don't just replace the TCM. You need to make sure all the other codes are fixed first. We're going to be wanting to check in the line pressure control circuit, solenoid, and confirm powers and grounds and everything to the TCM before we replace the TCM. So this code, in my opinion, is very misleading. Have to diagnose the rest of the other codes before you can diagnose this code. Alright, stepper motors. The one thing that not everybody is used to in the transmission industry, is kind of new for CVTs and for us transmission mechanics. So a lot of stepper motors get replaced for absolutely no reason because of these codes. You'll see a code P1777 stepper motor circuit. Notice it said circuit. That's a big clue right there when it comes to stepper motor codes. So what we basically have in here in the bottom left, we have, this is your stepper motor, and as the stepper counts change and they change the voltage to this motor, this pin extends right here and extracts. So what you have basically inside the stepper motor is you have 4 different coils, kind of like a starter motor or a motor, but you have 4 different coils in there, and as these coils turn on and off from the TCM signal, it will turn the inside of the stepper motor. It rotates, and there's a little gear in here that will make this pin go in and out. So as the coils turn on and off, the motor is able to turn one direction or the other direction to get this to extend or extract. So kind of hard to check the stepper motors themselves. The set conditions for this code, it says each coil of the stepper motor is not energized properly due to an open or short circuit. So each coil inside the stepper motor is going to have 15 ohms of resistance. So let's just say we want to test the stepper motor on the bench. So here's our looking into the stepper motor connector right here. It's very easy to do. We're gonna measure in between 1 and 3. That is going to 1 and 3 is going to give you 30 ohms. Then you can also measure 4 to 6 is going to give you 30 ohms. What we're doing there is we're testing 2 coils that equal 30 ohms. Another way of testing this is going 1 to 2, you should get 15 ohms. 2 to 3, you should get 15 ohms. So see this pin number 2, or ground, number 2 right here is ground. So it's a common ground between 1 and 3. Same thing here. Pin number 5 is ground, and you can check the resistance between 4 and 5. You should get 15. 5 and 6, you should get 15. You can do the same thing. Here's the transmission case connector. So if you went to ground of the transmission case and you went to pin number 9 at your case connector, you're going to get 15 ohms. If you went to pin 8, you're going to get 15 ohms. 7 and 6 are both going to be 15 ohms too. If you wanted to test the coils that are on the same side of each other, like the 1 and 3, you just test between 9 and 8, you should get 30, and 7 and 6, you should get 30. This is for design 1, design 2, and as far as I know, this is for all the Jatco stepper motors. Test the same way for all the different models. So I kind of went over all this on the last one. but let's kind of go over it again because I may have lost a few of you. Design 1. So we can do it at either connector, transmission case connector or the TCM connector. Let's just do the TCM connector because that's where we're at. So we're going to test pins 21 and 20. So a meter from 21 to 20, we're going to get 30 ohms because we're testing 2 coils. Test 12 and 11, so 11 and 12 right here, you're going to get 30 ohms. Now if you wanted to check each coil, we could go ground to the battery on your meter. In the other one, we test each individual coil. So at the TCM, we test 21 in ground, we should have 15. 20 in ground, you should have 15 ohms. 12 in ground, 15 ohms, and the same with 11 in ground. You can also do this on the case connector. Case connector is kind of small on these and kind of hard to get to. TCM is probably a little bit easier in my opinion. 1777, this is a design 2. Everything is exactly the same. The only difference is your transmission TCM connector numbers. We're just going to keep moving on. (1778), this is the most common code. Everybody sees this and goes, oh no, it's a stepper motor. Replace the valve body. Change the valve body or the stepper motor. Oh, it didn't fix it. Okay, now what do we do? This is stepper motor functions. So what it is saying here, and this is the biggest key right here, set conditions. This code detects when electrical system is okay, but mechanical system is malfunction. TCM is detecting an incorrect ratio. So all this is on the scan tool you will see stepper motor counts going up and down. Your ratio PID is not changing. It's gonna say P0 1778. It's blaming the stepper motor for no ratio change because the job of the stepper motor is to change ratios. So I have yet to see a failed stepper motor yet. I have heard of one stepper motor that had an open coil in it. I didn't see it personally, but I talked to them on the phone. So my advice to you guys is if you are getting stepper motor codes, make sure that it was either a function code or a circuit code. If it's a circuit code, do the test like I said I did on the last 2 pages. If it's a function test, it's not the stepper motor. Most likely you have a problem with the flow control valve sticking and a ratio control issue or a ratio issue because it's not changing ratios more than a stepper motor itself. All right, system restart. This is going to kind of get a little confusing and the factory information is a little mudded. So we're going to say this pattern A, do pattern A if the TCM, if replace the TCM and not the transmission. So pattern A, if we replace the TCM but the transmission is the original one. Pattern B is going to be if the TCM was not replaced and replaced the transmission with the new transmission or a used transmission. And then pattern C is if the TCM replaced with new transmission or new or old computer. So we have 3 different patterns. Most of the time we can do these steps and take care of the resets. So pattern A, if the TCM and not the transmission ROM was changed. So if we just replaced the TCM, this is what we need to do. Shift the shifter lever to the park position. After replacing the TCM, turn the ignition key to the on switch. Check the shifter position indicator on the combination meter turns on. It indicates approximately 1 to 2 seconds after turning the ignition switch on. So that's all we're having to do if we replace the TCM. Put it in park, turn the ignition switch on, and make sure the combination meter reads part properly. Pattern B, if we replace the TCM with used or did not change the TCM and replace the transmission with new or rebuilt. So basically pattern B is if you change your transmission ROM, if it's been replaced, or you got a used transmission, a reman transmission, something along those lines, or if you had to swap the TCM to a new or used TCM, it's going to want you to do these steps. So basically what we're doing here is we're relearning the ROM information to the TCM, or the TCM information is relearning the ROM. So they have to be on the same page. So basically after we do each part, we're going to turn the ignition switch on after replacing each part. So if you, let's say you replace the TCM, you're going to want to replace the TCM and turn the ignition switch on with the shifter in park, and you should see the indicator replace. Now we want to do that before we change the transmission. All right. So if we change the transmission first, they want you to change the transmission, turn the key on, and then we'll go back through pattern B again. Notice on line 2 it says connect the vehicle to the Consult 3 scan tool. That's the Nissan scan tool. They want you to start the engine. They want you to go over to the data monitor in the transmission. Sometimes this can be found in aftermarket scan tools under functional test. Need to warm up the transmission to the ATF temp count indicates 47, so roughly 68 degrees. And then turn the ignition switch off. So we're getting the transmission temperature up to 68 degrees, and then we are turning the ignition switch off. Then it wants you to turn the ignition switch back on. Select self-diagnostic results of TCM or transmission. It wants you to move the shift selector to the reverse position. Slightly depress the accelerator pedal to where on the accelerator pedal it shows 2 of 8, so roughly a quarter throttle. While depressing the brake pedal, select erase. So you have your gas at a quarter throttle, you have your foot on the brake, engine's off during all this, and then they want you to erase it. Select erase. Step 11, they want you to release the brake pedal and the accelerator pedal. Turn the ignition switch off, leaving the selector in the reverse position. Wait approximately 10 seconds. Turn the ignition switch on, keeping the selector in the reverse position. So we are continuing on to pattern B. Select special functions in transmission. Check that the calibration data and Consult 3 data is the same as the data listed in the table below. So you're looking at calibration data 1 through 6, and you want it to be zeros on all these. Shift lever to the move the shift lever to park. Check to make sure that the park indicator is reading correctly. So that's how you do it with the factory scan tool. Other stuff that you can do with some of these aftermarket scan tools, you can do the TCM or TCM ROM initialization. Sometimes they're in the engine side, sometimes they're in the transmission sides. Best luck is with the OEM tool, of course, but some of the aftermarket tools are now starting to do these. But the main thing is, after you do these resets, go back into your calibration ID and make sure all these values are 0. You should be able to see this on your aftermarket scan tools. Not all of them are going to have that, so a little warning there. Pattern C, new TCM and new or old transmission ROM. So basically what this is saying, it says replace the transaxle first, then replace the TCM. If you have any issues where A and B didn't work, they want you to basically perform patterns A and B again. So all transmissions after rebuild or installed different units need to do the reset. Some of the aftermarket scan tools can perform resets, but others do not and may need a factory tool. Reset the G sensor, steering angle, calibration data needs to be cleared, and throttle body. Also do not forget to make sure that you have the latest program installed. This will conclude your chapter on diagnostics for the jf010e jack code CVT transmission. We want to thank you for your participation in Beautiful Training Solutions powered by ATRA. Until next time, let's keep fixing transmissions together.